Hello, and thank you for joining me today. Today we're going to be going over the concept around Openstack API benchmarking and scaling. This has always been something that's been of interest to me, primarily because of my background dealing with production support and dealing with services. And the idea around understanding how those services scale when under variable amounts of load just gives you a clearer understanding as to what to expect, and also gives you an understanding as to the strategy you can follow when it comes time to needing to scale out those APIs. For this exercise, I used a tool that is something that I was very used to using, and it happens to be open source, just like Openstack and a lot of the other tools I prefer to use. The tool's name is SOAP UI, and if you're not familiar with it, I would definitely encourage you to go online to SOAP UI website and explore it, download it, and kick the tires for yourself. So what I have up on the screen here is actually the SOAP UI version on steroids, as I would call it. This is a package that is not free like SOAP UI, but it does include additional load testing tools and features that SOAP UI does not have. And it's actually called Ready API. It's made by the same software company. And what it basically does is incorporates Load UI, SOAP UI, and a few other tools that they have all into one unique dashboard. So that's what I have up on the screen here. And the first step in dealing with the Openstack APIs, as we all are probably very clear on, is that you need to be able to authorize yourself and be able to get back that authorization token. And then at that point, you can use that token over and over again with all your subsequent API calls that you make. And what I'm going to step you through is what I've kind of outlined in the blog post that's associated with this demo video, and step you through the different areas or the different requests that I made and how they're structured and how I use the tool to be able to get that information. So if you just want to follow along with me for a bit here, and I'll step you through how to go about getting that token, what that looks like within the tool, and then at that point, what I do with that token and how I can populate that into all the subsequent requests that are then made. So follow along with me here as we kind of jump into the tool. So again, as I mentioned before, this is the dashboard of SOAP UI, or actually Ready API. SOAP UI's dashboard looks very similar in the sense that the only difference would be is you would just see a projects tab, and then your projects would be listed here. Within SOAP UI, project is just called a collection of API requests, whether it be RESTful SOAP API requests that you make, and then you would basically populate each request with the specific parameters, the URI, any additional resources that you append to that the URI, and of course your request body, and then of course on the right here you would get your response. So this first example is, I call it get token because it's exactly what it does, right? So we're going to send a post request to our Openstack API, Keystone API to be exact, because we're dealing with port 5000, and that's Keystone. We're going to send a pending resource to that URI to be able to get a token. So if you look into the openstack.org and you look at the API guide, this is actually the URI that you would need to add to your endpoint to be able to request a token. And down here in the center part is where we're actually having our actual JSON request. And within that JSON request, I'm passing all the necessary information needed to get back authorization token, or authentication token to be exact. So I'm going to basically pass my admin, the username, what domain, the password, all right, all the normal information. And if we click on this button here that looks like a play button, it actually will submit this request and then be able to log the response on the right window here once that request is made. So let's click on this here. So once we click on it, we see that we got a response back very fast, actually so fast that you probably didn't even know that you executed it. You can see by the date and timestamp that execution did go through. The HTTP response code is 201, which is a thumbs up. That's the type of code you want. You want anything between 200 and 300. Those response codes are exactly what you're looking for. And then what you'll note here, and then one change in Keystone, the version 3 of the Keystone API, is that the token is no longer appended to the body of the response. The token is actually appended, or can only be found in the header of the response back from the API request. So because we're looking at the raw response, we can actually see that the header value here, and this is our token. If we were looking at it from a JSON perspective, it would look something more like this. right? And this is kind of a bit harder to read, but again, the token is actually not in this body. The token can only be found in the header. So the token is always found under the header parameter of X subject token. And this is our token here. So what we're going to do is we're going to grab this token. We're going to just copy it. So I just want to grab it all the way to the end there and make sure we have the complete token. As you can see, it's a pretty long token. We're going to copy that. And what I did in this project is I defined a custom parameter. So if we go back up to the project level and we go into custom parameters, you'll see here that I created a parameter called XAuth token. And what that parameter is going to do is I've basically configured every request to be able to read that parameter. So it's going to read this token value in dynamically, and then when I execute that request, it's going to take that token and use it every time. So now let's say, for example, if I want to list the projects, so I'll go into list projects request, you'll see that under the request, there's actually a property being passed here, and that property is reading in that custom property that I've defined at the project level. So you can see how you're reading in that variable by calling the project and calling the custom property name. Right. So again, remember, we looked at it. The custom property name is XAuth token. We're going to call up our project level, and we're going to call that token in. So the value that's going to be passed here is going to populate from what I've put into the custom properties. And if we look at it from a raw request perspective, you'll be able to see that information being passed once we execute it. So because I have my token information, I should be able to submit this request again to Keystone's API, and I'm going to have it list out all the tenants or projects that are available within my cloud. So let's execute that guy. And on the right, we see we have a response. And what we're going to do is we're going to look at the JSON response because it's a bit easier to read than the raw. And we'll see here that the only project or tenant that we have running that I'm able to see is the admin project, which of course we all know is one of the default projects that are created when you install Openstack. Specifically, this cloud was deployed using OSA. So again, the admin, tenant, and project, as well as the service project, is the default projects that are created when you install your cloud. So we can see that the token is working. We can see this request worked as expected. And if we look at the raw request, now that we've executed it, this is what the raw request looks like. We can see that our token was added to that HTTP header, and this is our token value. And this is why we were able to get back a successful response from the server. So now that we've kind of gone over the basics, we're going to jump into kind of being able to demonstrate the test scenario that I created that was mentioned in the blog post associated with this demo video. So to do that, I'm going to jump over to this tab here that says SOAP UI NG. And as I mentioned before, this is SOAP UI on steroids, meaning that it incorporates a lot of additional features and functionality that's built into it. And the reason why I'm using this tool is it's kind of made it easier to be able to do the type of testing that we were kind of wanted to demonstrate here. So as we can see here, I have a test case called OS API benchmark. And within this test case, you can see that I'm making quite a few requests. Again, these requests match exactly up to the tests that I ran and the stats that I provided in the API benchmarking blog that was created. As in the blog, if you got a chance to review it, you'll remember that these are the 10 steps that we went through and stepped through. Initial service requests, creating of a server, the server list again, getting the information such as the server ID so I can pass it a subsequent request, such as creating a snapshot, resizing a server, confirming, which is just a required step when you resize a server. Then of course the last step was delete. And I just wanted to kind of take 1 second and look at this one step in the test case in particular, just to kind of give you an idea as to how I was able to pass not only that token, but as well as passing other parameters that were needed for a successful execution of the API request. So if we look at the create server request, if we're familiar with Nova's API, we know that the port that it uses is 8774, which is what we're going to request here. or as well as we're going to need to append to that URL this URI of version 2.1 slash and whatever the tenant name is. And the way I'm populating that information is through a variable that I'm passing, or a property that I created. And that property is called tenant ID. And what I'm actually able to do is take a tenant ID that I was able to get when I ran this, when I ran the previous test back here, when I did under listing out our projects. I was actually able to grab that ID, and then what I did is I used that ID to populate this variable. Again, you can make that more of a dynamic thing if you wanted to. You can have it read that previous request and take that information and populate it here. I didn't do that because it wasn't necessary. I was dealing with one project, but that is something you can do. That would be very similar to what we're doing here, and I'll go over the get server ID step in a minute. So now that we're populating our URI with that tenant ID, the next one is also grabbing the token, just as before. You have to pass that token with every subsequent API request. Without that, Keystone will basically say, I don't know who you are and you're not authorized. The other final piece of the puzzle is looking at the JSON body that we're going to pass in that API request. And again, this is a standard JSON body that you would need to be able to tell Nova to create an instance. All the necessary information is passed, the general name you want to provide, the image that you want to use, whatever flavor you want to use, the key that I'm going to have inserted into each instance that's created, the max count. So basically I can tell it to create 1 server, 2 server, 5 servers, 20 servers, right? So for this API request, the body here, we're going to tell it to create 5 servers. I'm going to tell it to use the default security group. And last but not least, I'm actually passing in some user data. And what this user data is, and first off, let me be clear that this is encoded. Base 64 encoded. This is a requirement. In order to pass user data using the API, you have to encode what you want to pass as far as the user data. And I use a very nifty tool, online tool, to be able to do that I can share with you guys later. And basically what this exactly does, this code is actually encoded code. Actually, all it tells us is to run a script when it creates that instance that will basically tell the instance to utilize all of the CPU. So basically, I want to simulate creating load on your compute nodes once it creates these instances, because I wanted to give it a real life type of test scenario. I didn't want it to be create an instance that instance is not doing anything. So whenever every instance that's created, it actually will generate some fake load to make the CPU of that instance tap out to at least 99 or 100% utilization. So that's what I'm doing there in the user data. Another very unique step that I wanted to kind of show you here is called the get server ID. And the reason why this step is important is in order to execute a snapshot or resize or even a delete request, you need to be able to have instance IDs. And in order to be able to do that, what I did is I had it execute a step that's going to go out and list the instance IDs. And we can see here, if we look at the JSON of this is an example. So basically, I had it list out all the instances that are running under this particular project. And what I'm having this step do, get server ID, is basically take the information from that previous request, from the response, and basically pluck out this information from that JSON request. That JSON response. And I'm going to have it do the same thing for instance 1, and you can see how the variables there change from 0 to 1, and I'm going to have it do it for instance 10. You can see how the variable changed from 1 to 10. And then there's one other step in here where I'm going to actually have it confirm the resize of instance 1, so I had to also pass that information. But again, I'm going to pluck that information from the previous request servers list, its response, and this is what I'm going to pull out of the JSON path. And what I'm going to have it do is I'm going to have it take that information and put it into the next request, which is confirm resize server, which is that guy there. And I'm going to have it populate the property server ID. And if we go and look at that request really quickly, we'll see that we have a property named server ID. And what it's going to do is it's going to take the information it pulled from the server list request and put it right in here as a variable, so that when it goes and executes that request, it's actually going to append it right to the URI there. Pretty cool stuff, right? Excellent. So now that I've kind of taken the time to kind of break down some of those very interesting things, a few things that I also had to do is I had to make in some delay time to do the build. So basically this is going to delay the script from running for 20 seconds while the servers are built So remember, before that, I'm going to tell it to create 5 servers. I usually like to give 1 second per server that I'm creating. Originally, this script was created to be able to build 20 servers. So what I'm going to do is I'm actually going to go back and make this adjustment here. And I'm going to tell it to build 20 servers instead of 5. And now that I have it configured to do that, I'm going to execute this guy, and let's see what happens. So we're going to go back up here to the top of this test case that we created. Now that we've made our change to this script there to create 20 servers, we're going to give it a build time of 20 seconds. And then I've also, one other really quick thing I wanted to recap is we're going to also give a delay for the resize, because the resizing of a server obviously takes time too. It needs to bring the instance down, do the resize, bring it back up, and I'm giving it about a 10-second delay there to do that. But again, you can adjust these timing based on what you feel comfortable with. So again, now we're going to go back to the top. We're going to actually run this guy, and then we're going to see some very quick results. So let's do it. So now it's stepping through the test case and going through each step, and you can kind of see here how it's dynamically doing the wait, right? It's built in that 20-second wait, so it's doing its countdown to let you know where it is as far as running the test case. So it'll be done very shortly here. Okay, it's moved on. It got our server IDs and it stored that information for the subsequent requests. Now it's doing the resize delay, and we're going to wait on that there. That's almost done, and now it's done, right? So if we go in and look at the transaction log, we'll see here that it actually captures the information about each step, how long each step took. And don't let this bother you about the status being unknown. It doesn't know how to interpret the response of the API. Every API's response is different. I wish it would read the HTTP code that it responds with, but apparently the tool doesn't. So don't let that part jar you. But we do see that all the steps did pass, and it was successful. So if we flip over to our environment really quickly and we log in, we should see 20 instances that are created, as well as we should see 1 image, because we took a snapshot of an instance, as well as we should see 1 server instance that was resized from a tiny to a small, and the last thing we should see is that one of the instances should have been deleted. So if we go in here to our instances, we should see that we have 20 instances running, and we can tell that by our count there. We'll also note that there was 1 instance that was resized from tiny to small, and we can see that was successful there. We will also note that instance ID number 10, so API bench 9 and 11 are there, but you notice that API bench 10 is gone because that was the instance that we deleted. And the last step, we should go over here and we should see a snapshot or an image that was created, and we can see that snapshot and image is created there. So that basically concludes what I wanted to kind of show you today with SOAP UI and doing some API benchmarking with the Openstack services. Please, as always, let me know what you think, and I appreciate you guys hanging out with me today. Enjoy your day.